Problem number 2 on the exam is asking you to find the integral that calculates the volume of a given solid. And it describes that solid with a base that is a triangle enclosed by x plus y equals 5, and the x-axis and the y-axis. So it's this area in here is the base. Now it also describes that the cross sections perpendicular to the y-axis are semicircles. So what that means is that if I was looking at this as a three-dimensional object, what I would actually see is I would see like a triangular base with a bunch of semicircles going across it, because it says that it is perpendicular to the y-axis. So what we need to do is we need to find the volume, and all we're going to use is we're going to use the same formula that we would use to find any sort of disc or washer. All we're going to have to do is we're just going to have to modify it a little bit due to the odd nature of the volume that it is generating. So first off, let's figure out what our radius needs to be in this case. So the way that we normally do that is we want to find what our radius is going to be. So in this case, if I was to extend a small rectangle across this way, and the reason I'm doing it this way is because it says the semicircles are perpendicular to the y-axis, which means that my radius has to be perpendicular to the y-axis as well. This would insinuate that I have some sliver dy. So that means that I'm going to take this rectangle and I'm going to move it across here with my integration to get the full volume of that solid. So I can go ahead and start writing my equation out. I have pi integral. Now I know my radius in this case is going to have a dy. So now I just need to figure out what that r squared value is going to be. So the distance across of this triangle is going to be, well, if I need it in terms of y, I would need x equals 5 minus y. And again, the reason I'm getting it in terms of y is because I have a dy because of the nature of these semicircles. So remember, I want all my variables to be the same variable. I don't want to put x in here because then I can't integrate it. So if I have a dy, I want everything in terms of y. So now, what I can do is I can go ahead and I can sub that in. But now the question is that my radius? Well, in this case, we have to think a little harder because the way that it describes the problem, the distance across here is an entire semicircle. The entire distance across of a semicircle is the diameter. So, in reality, this distance across is not r, it's 2r. But I don't want the diameter of this solid, I want the radius of this solid. So to get the radius of the solid, what I actually have to do is I actually have to divide this by 2. By dividing this by 2, this is now the radius of my solid. So this would be somewhere around the middle point of each one of those semicircles as it goes up. So instead of just plugging in 5 minus y over 2, I'm going to plug in 5 minus y, instead of just plugging in 5 minus y, I'm going to plug in 5 minus y over 2, and then I'm going to square it. So what I actually end up getting is I end up getting 5 minus y squared over 4. Okay, now we're almost done, because again, all we have to do is you just have to set up the integral. We don't have to actually solve it. So I need to figure out my boundaries also. So if I'm taking my dy and I'm extending it from here to here, that means that I am going along the y-axis from 0, and when I reach the very top point, when x is equal to 0, my y value is equal to 5. So the entire extent of this solid is going to be 0 to 5. Now there's one last thing that I actually have to take into account, and I actually have to take into account the semicircles one more time. So if I think back to disk method, this is how I find the volume of a total disk. But I don't want the volume of a total disk. I only want half of that volume. It's not a full circle, it's a semicircle. So in reality, it would be as if I was cutting off half of this disk, just leaving it right there. So if I'm cutting off half of the area, I need to take my equation and I need to divide it by 2 one more time. So if this equation is how I find the volume of a full disk, pi over 2 is how I find the volume of half of a disk. And again, the reason is because it's bounded by these semicircles. So I'm only finding the volume of half of a disk. So when I go through and I actually work this out and complete the math, I end up getting pi over 8 integral 0 to 5 of 5 minus y quantity squared dy. And that would be my final answer, which if I look at my answers to pick from, I end up getting letter B.
The Teaching Center, UF's Learning Resource Center.